Okay, today we're going to do a pretty cool experiment here. We're going to basically figure out the density of carbon dioxide. So if you look, I've got some basic lab equipment set out in front of us here. We have a pegboard, we have a test tube, we got a little clamp. Underneath here we have, as you can see, there's an alcohol burner there ready to go. We have a bucket, which is about 2/3 filled with water. We've got a jar and a rubber band. We've got this little device here, which I call a gas retrieval system. You can see this basically plugs into the top of the test tube. And we've got baking soda, scupula. I've got what could be on your science notebook, but I did this on a little whiteboard. Some basic calculations here, a little data sheet, if you will, and then we have a triple beam balance. So essentially what we're going to do today is we are going to heat up some baking soda. And so you're going to watch as we go through and look at this here. And what we're going to do is essentially we are going to take this test tube. We're going to get a small amount of baking soda, maybe 2 of those scoops or so, something like that. And we are going to heat it up over the alcohol burner. And one of the things that baking soda releases when you heat it up is carbon dioxide. And that's what, if you are a baker yourself, that's what gives all the little air pockets inside your banana bread or whatever it is that you bake. That's some of the gas that's released, and that's what gives baked goods their fluffiness, if you will. Okay. So the first thing that we'll do here, after I added my baking soda to the test tube here, is we're going to go ahead and take, as you can see on the sheet there, we need the mass of the test tube and baking soda before. So we're going to go ahead and put those on the balance like this. We're going to go ahead and balance this out. And again, I'm using a beaker, you can see here, because it's just dangerous to put a nice smooth cylinder on a flat surface and not expect it to roll off and shatter. So as long as I have the beaker here for both before and after, it's not going to make any difference because we'll still be able to tell the difference in weight. So it looks like I'm at 100, 60, 50, 40, there we go. So we're going to be in the 140s. So if we look here, we're going to be, let's see, right in the 147, just under 146 range. And you can tell at right there that we are balanced, so we are at 146.5 would be our starting mass before. So again, we're looking at the mass before. We said we're at 146.5. And again, that's all of the baking soda before it's heated. So now we're going to go ahead and take that and set it up over here. And I'm going to show you a couple things here. We're going to pause for a second, but we'll take the baking soda, we'll snap that into this little clip here. Then we're going to go ahead and take what's called our gas retrieval system. We'll snap that in tight there. And now we got to figure out a way to collect this gas and measure it. So what we're going to do essentially is we are going to fill this jar up completely with water. And then we're going to invert it inside the bucket so that there's water, nothing but water inside this jar. We'll run this tube, up into the jar, and then any gas that's created from this baking soda will be collected inside this jar. And I'm going to show you a little trick on how to fill up this jar in a second while I also fix this clamp. Okay, so here's your little trick. Because you can't have any gas in this bottle to begin with, because you want all of the gas that's been collected in this bottle to actually have come from the baking soda. And if you start with gas in here, it's going to throw off our measurements, because obviously we're measuring a very small amount of gas. So what you're going to do is you're going to fill this bottle up. And I have here a little half note card. And I've got my white bucket from earlier. I brought it in the sink here if you can see that. So I want to fill this up so that you have essentially a convex surface over the top. And then what you're going to do is you're going to push that index card like that over top, and notice there are no bubbles. Now I'm going to completely submerge this, and now I can draw the index card out. And the reason I had that rubber band on there earlier is I'm going to slide half the rubber band up the side, as long as it doesn't slide and snap and spray water in my face. You're going to hook this over this little part of the bucket, and it will essentially balance there. And I'll carry it back to our lab station where we'll pick up next. Okay, so now that I've got this bucket over here, I'm going to be very careful, and I'm going to slide this tube up into the bottle itself. And it doesn't have to go that far. I usually slide it up about 1/3 of the way. And so now what's going to happen is, as we heat up this baking soda, which I'll light right now, I'm going to light this guy here. And as we heat up this baking soda, we're going to very quickly start to see bubbles. You're going to start to see these occurring. Let's see if I can zoom in a little bit here. You're going to see those quickly accumulating in the bottle. I'm going to let this go for a little while. I don't want to let the bottle overflow. I'll leave this here. My rubber band just kind of slipped off, so I'll carefully connect that back while we're waiting. But now you can see, you can really see the bubbles are really cranking along now. You can see from the side that it's starting to displace. I'll kind of turn you sideways here, but it's starting to displace quite a bit of liquid. So I got to be careful here, so I want to watch for this. Again, we're just heating up that baking soda over there. I want to watch for this, and I don't want to let the gas fill up the bottle so much that the gas starts to push out into the bucket itself. You can see there's no gas bubbles in the bucket itself. It's all going into the glass bottle. I'm going to wait until that is about, like I said, maybe 2/3 full. I'm going to have to keep an eye on it, because once the level of gas goes below the top of the rubber tube, I won't be able to see the bubbling occurring anymore, because the gas is going to be released into the gas that's already in there. It's nice when it's going through the water, because you can easily see that. So I'm just going to monitor that for a few minutes. It doesn't take very long. At this point, I can see that the water level is pretty low, so I'm actually going to blow out the flame at this point. And what I'm going to do is really carefully, I'm going to hold the top of this jar. I'm going to lift, but I cannot lift the bottom of the jar out of the water. I'm just going to remove the tube, and I'm going to slide this rubber band down. The rubber band actually becomes my marking device. So I'm going to mark the level between where the water meets the gas. So all this gas trapped in here right now is the carbon dioxide that was created by heating the baking soda. So it was released from the baking soda. It's not in the baking soda anymore. There's still some left in there because it was still going, but this is what was collected. So again, I'm just marking this. All the rubber band is doing is marking this. I'm pretty good. I want it as flat as possible. If you haven't figured out what I'm doing with this yet, you soon will see. Okay, so that marks, this is gas. Right at this line, it's liquid left down there. Now what I can do is I can release that. What we're going to do next, you will see. So what we will need is graduated cylinder. We will need this jar, which essentially, as you can see, this is the amount of carbon dioxide that was collected from that baking soda. Can anyone figure out what we're doing with this next? Well, what we're going to do, follow me over to the sink, is we're going to come back to our handy dandy sink, and I'm going to fill this container up to the line. So I am now going to use water to take the place of the gas that was in there, but only for measurement purposes. So that's a little much. Dump that out. So essentially, this water is now being used to take the place of the gas that was in there earlier. And so what I can do now is I can go back over to our table here, is I can start pouring this into the graduated cylinder. So as I do this, I want to do it 100 milliliters at a time, being very careful not to spill. Just put a little back, don't make a mistake. Try to be as accurate as possible. There's 100. Mark that down. 100. Much closer that time. 200. 300. Getting close. 400. Oops, almost dumped the wrong one. It's 400, and we're going to be 400 and change. So let's see here. So the volume of our gas was, looks like right about, you can see that, I know it's hard to see from camera. I'll look at it from eye level. Wow, right on the mark, 450. It's a nice even number to get. So what I'm going to do is go over here. I'm going to write volume of CO2 collected here is 450 cc's or milliliters. Okay? So I also need the mass of the test tube and baking soda after. Now this should be cooled down enough that we can remass this at this point. So let's see what this looks like. So I'll pull this off of here. We're going to put this back on the balance. And you'll notice I left it sitting where it was before. It was at 146.5. It's now lighter. I'm going to have to slide this back. And I've got, as you can see, 145.4. So my mass of test tube and baking soda, double check my numbers here, 145.4. Now all we have to do is look at how much was lost. How much baking soda was lost in this situation? Went from 146.5 to 145.4, which tells us that essentially we lost, 1.1 grams. At this point, we know that the mass of the baking soda lost, or the carbon dioxide lost, pardon me, I should have corrected that. It should be mass of carbon dioxide lost. Let's just change that. Was 1.1 grams. we collected 450 cc's. So that's how much we collected in this jar. And so essentially, at this point, we just need to take 1.1 divided by our handy-dandy calculator here. We do 1.1 divided by 450 equals 0.002. Density of the carbon dioxide is 0.002 grams per cubic centimeter. Look it up. We got really close. That's great.